Good afternoon, everyone. So, in today's session, we'll be starting with the new chapter that will be alternating currents, and we'll be discussing some of the important questions and PYQs of alternating current, right? So, the first question, starting with the first question on the screen, is that find the time taken by the current to reach I naught by root 2 if the frequency of the given current is given as 50 hertz, right? So, the question here is that we have to find the time taken by the current to reach I naught by root 2 if the frequency of the current is 50 hertz. So this is nothing, this is the RMS value of the current, right? It's the RMS value of the current. Let's suppose if current I is equal to I naught sine of omega t, right? The input sinusoidal current is I naught sine of omega t, right? Where I naught is the amplitude of this current, that's the peak value of this current, right? Omega is the angular frequency, right? And this omega is nothing, it's 2 pi times the frequency, right? The value of this I naught is I is given as I naught by root 2. So it will be I naught by root 2. That will be equal to I naught sine of omega t, right? So from here I naught and I naught will get cancelled. So omega t has to be equal to that's 1 by root 2 sine of omega t is equal to 1 by root 2, right? It means that omega t has to be equal to pi by 4, right? Pi by 4. Or from here, the value of t will be nothing. It will be equal to pi upon 4 times omega, right? Pi upon 4 times omega. Now, omega will be 2 pi times frequency, right? We can write it as 2 pi times the frequency. Here is 50 hertz, right? Pi and pi will get cancelled. So we'll be having 1 upon 400 seconds, right? So this much will be the time taken by the current to reach I naught by root 2, right? So that's peak value upon the root, right? Now let's move on to the another question, right? If an AC supply, main AC supply is given to be 220 volt, what would be the average EMF during the positive half cycle, right? So let's suppose that we have to find the average EMF during the positive half cycle, right? The average of any function, right? Or RMS value of any function, right? That's how we can calculate the average of any function or RMS value of any function, right? Now let's suppose we have been given an alternating current, right? Or alternating voltage that's a function of time, right? This is how it varies, right? Sinusoidally, or we can write it as v is equal to v naught sine of omega t, right? Where v naught is nothing, it's the peak value of this voltage, right? Omega is the angular frequency. Now if we have to find the average during a positive half of the cycle, right? So this is the positive half of the cycle and this is the negative half of the cycle. So from here to here, it's a complete time period t, and from here to here, it will be the half of the time period, that's t upon 2, right? And the time period is nothing. Time period is nothing. That will be equal to 2 pi upon omega, right? 2 pi upon omega will be the time period, right? So time period will be nothing. It will be 2 pi by omega. So this will be the time period. We know that omega is nothing. It's 2 pi by t, right? So time period will be 2 pi by omega, right? So from here, we have to calculate the average value during positive half of the cycle, right? So we know that average of any function, be it any function, is calculated using this integral f of x dx upon integral of dx, right? With the limits x1 to x2 and from here x1 to x2. Similarly, if we have to find the average of EMF, right? Then the average of the voltage will be nothing. It will be integral of, since voltage is a function of time, we'll integrate it with respect to time. That will be VDT with limits t1 to t2 upon integral of dt with limits t1 to t2, right? Now from here you can see here the value of the V is given as that's V naught sine of omega t, right? At dt, right? With the limit 0 to, for half of the cycle, the limit will be half of the time period, right? 0 to t by 2. So from here, we'll have the time period t by 2 here, right? Integrating the denominator, right? Or we can write it as 2 upon t integral of v naught sine of omega t dt with limit 0 to t, right? 0 to t. Now we have to integrate this function 0 to t by 2, not t, 0 to t by 2. Now integrating this function, right? 2 by t, the integration of sine of omega t will be minus cos of omega t, right? It will be minus cos of omega t and divided by omega here, right? Divided by omega here, right? With the limits 0 to t by 2. With the limit 0 to 2 by 2. So we'll have minus 2 upon omega t here. So upper limit minus lower limit, right? So it will be cos of omega t by 2, right? Minus cos of 0, that's 1, right? That's 1. I can see here cos 0 is actually 1, right? So now you can see here omega t by 2 will be nothing. You can write it as 2 pi into t upon 2, right? So this and this will get cancelled, right? And this t and t will get cancelled. We'll be left with pi only, right? The cos pi is once again minus 1. So minus 1 and minus 1 will be plus 1. It will be minus 2, minus 1 and minus 1. It will be minus 2. Minus 2 multiplied by minus 2 will be plus 4. Or we can write it as 4 upon pi omega, right? 4 upon pi omega. We can substitute the value of omega here, right? We can substitute the value of omega here, right? So omega will be nothing 2 pi f, and substituting the value of omega will get the average value, right? So this is the average value during the positive half of the cycle, right? This is the average value during the positive half of the cycle, right? For this V naught sine of omega t, right? For the AC supply to be 220 volts, right? Now let's move on to the next question. That's the calculation of the RMS value, right? We have to calculate the RMS value of the AC current, right? To calculate the RMS value, it's important we can just go by the reverse direction, right? In the opposite direction. That scare the function, take the mean of the function, and then put the root on that mean square, right? We'll get the RMS value of that function, right? So let's suppose if we have V1, V2, V3, V4, these are the number of values. And if we have to find the VRMS here, what we'll do is that we'll just first of all square them. That will be V1 square, V2 square, and take the mean of them, right? So we'll take the mean of them. So these are 4 terms. We'll divide it by 4, right? And at last we'll be taking the root to them, right? We'll just put a root here, right? So this will be the VRMS value, right? So this is how we can calculate the RMS values, right? Similarly, here we have to find the RMS value for this current here, right? So what we'll do here is that we will just square the current first, then find the mean square of this current, mean of this current. Then after finding the mean of this current, right? After finding the mean of this current we can easily find the RMS value of this current, right? So I is given as that's equal to 3 plus 4 of sine of omega t plus pi by 3. Omega t plus pi by 3, right? That's the value of current, right? So the value of the current here is given as 3 plus 4 sine of omega t plus pi by 3, right? Now, first of all, what we'll do here is that we'll just square this current, right? So if we square this, it will be 3 plus 4 sine of omega t plus pi by 3 whole square, right? So we'll just expand it. It will be 9 plus 60 sine square omega t plus pi by 3 and plus 2ab, right? It will be 2 into 3, it will be 6 into 4, it will be 24 sine of omega t plus pi by 3, right? Now we have just evaluated the I square, right? Now we have to find the average of this function, right? We'll just find the average of this function, right? So we'll take the average of this whole function, right? Now the average of 9 will be, it will be 9, right? It has to be 9. And the average of, average of sine theta for the complete cycle, right? Average of the sine theta for the complete cycle, right? For the sine theta or cos theta for the complete cycle, it's always equal to 0, right? And the average of sine square theta and cos square theta for the complete cycle It's actually equal to 1 by 2, right? You need to remember these two, right? Now, the average, taking the average, we'll be getting this average of this function, right? Then the average of this sine, 16 sine square omega t plus pi by 3, right? And we have to take average of this function as well, right? Omega t plus pi by 3, right? Average of sine theta is 0, right? So the average of this function will also be equal to 0, right? And 9 is a constant, its average will remain as 9, right? And the average of sine square theta is actually half, so it will be 16 upon 2, right? That's equal to 9 plus 8. The 9 plus 8 is nothing, that's equal to 17. Now this is the mean square value, right? 17 is the mean square value. To calculate the RMS value, we have to just take the root of this function, right? We'll just take the root here, right? So taking root on both sides. So this is nothing, this is the IRMS, right? This is nothing, this is the IRMS. So this is how we can calculate the RMS value of any function, right? Just first of all square the function, then take the mean of that function. After calculating the mean of that function, take the root of that function, you will get the IRMS value, right? Or RMS value of that function, right? Now let's try to calculate quickly the RMS values of these two functions, these two questions, right? So I is given as a plus b sine of omega t, and I is also given as a sine omega t plus b cos omega t, right? Now we have to find their RMS values. What we'll do here, we'll quickly square these two functions. So it will be a plus b sine of omega t whole square, right? We can just expand it. It will be a square plus b square sine square omega t plus 2ab sine of omega t, right? Plus 2ab sine of omega t. So this is the value of I square, right? Now we'll just take the mean of this I square, right? That will be b square sine square omega t plus mean of this 2ab sine of omega t, right? Now the mean of this sine of theta will be sine of omega t is always equal to 0, right? For the complete cycle. And a square is a constant, so its mean will remain as it is. So p square here is also a constant, it will come outside, and mean of the sine square omega t will be half, right? It will be 1 by 2. So this is the mean square value of the current, right? And to calculate the RMS value, we'll just take the root on both sides. So taking the root on both sides, we'll get the RMS value. So this is our RMS value. So this is nothing, this is IRMS, right? This is nothing, this is IRMS value, right? Similarly, if we calculate the RMS value of this function, what we'll do is that we'll just follow the same steps, right? Let me just erase it. So we'll just follow the same steps here, right? We just square this function first. That will be I square a sine of omega t plus b cos omega t whole square, right? B cos omega t whole square. So now just expanding this function, right? It will be a square sine square omega t plus b square cos square omega t, right? Plus twice ab sine of omega t cos of omega t, right? So this is the value of I square, right? This is the value of I square. So we'll just take the mean of this I square, right? That will be the mean square, right? So it has to be a square mean of a square sine square omega t plus mean of b square cos square omega t and the mean of 2ab sine of omega t cos omega t, right? Now, the mean of sine square omega t is nothing, it's a square by 2, and the mean of cos square omega t is also half, that will be b square by 2. I can write this mean of, this is nothing, We can write AB multiplied by 2 sine omega t cos omega t. We can write it as sine of 2 omega t, right? And the average of sine of theta is always equal to 0 for the complete cycle, right? So I square will be nothing. It will be equal to a square plus b square upon 2, right? So we will just take the root on both sides to calculate the RMS value, right? That will be equal to IRMS, right? So this is the IRMS value, right? This is how we can calculate the RMS value of different functions, right? This is how we can calculate the RMS value of the current, right? Now let's move on to the next question, right? The question is The question is that if V1 is equal to V naught sine of omega t and V2 is equal to V naught sine of omega t plus pi by 3, then find the resultant of the two voltage, right? So we can just find the resultants of the two voltages using the phasor diagram. It means that we can represent these two voltages as the phasors, right? Let's suppose this is the V1, right, along x-axis, right, giving initial phase equal to 0, right? And V naught sine of omega t plus pi by 3, it means at t equal to 0, it will have some phase, right? That will be pi by 3. It means the phase difference between V1 and V2 here is pi by 3, right? So their resultant will be nothing. VR, that will be equal to under root of V1 square plus V2 square plus V1 V2 cos of phi, right? Cos of phi. Now phi here is nothing, that's equal to pi by 3. That's 60 degree, right? Cos 60 degrees is 1 by 2, right? So the amplitude here will be nothing. It will be actually equal to V1 square. It will be V naught square plus V naught square plus V naught square upon 2, right? Or it will be V naught plus V naught under root of 1 plus 1. It will be 2, or we can write it as 5 by 2, right? So root 5 upon 2 V naught. This will be the peak value of the resultant, right? This will be the peak value, right? This is nothing. This is the peak value of the resultant. Right? So this is how you can find the peak value of the resultant of two voltage using the phasor diagram, right? Now let's move to the next question. In given circuit, applied voltage V is equal to 50 root 2 sine of omega sine of 100 pi t volts and ammeter rating is 2 ampere. Then calculate the value of L, right? So there is some circuit, right? Inductor in the circuit, right? Let's suppose this is the circuit and there is some AC supply in the circuit, right? So this is the circuit all about, right? Now in this circuit there's a connected ammeter, right? And the current measured by this ammeter is nothing, that's actually 2 ampere. And you know that in a AC circuit the current is a variable quantity, right? Whenever we say that the ammeter is reading a 2 ampere current, we mean to say that it is actually the RMS value of the current, because we know the current is actually a variable in AC circuits, right? So current cannot be a constant in AC circuits. It's a variable current, right? So whenever we say that ammeter reading is 2 amperes or 3 amperes or 4 amperes, it means that we are just talking about this value of the average. That's the IRMS, right? So IRMS value is given as 2 amperes, right? So 2 amperes is the IRMS value, right? So if this is the IRMS value, right? 2 amperes is the IRMS value, right? We know that VRMS is nothing. VRMS will be equal to, that's equal to IRMS, right? Multiplied by the resistance offered by this inductor, that's given by XL, right? XL. The value of this XL is nothing, that's equal to omega L. And VRMS is nothing, is the peak value. VRMS is nothing. It's actually the peak value upon the root 2, right? Here V naught is the peak value, right? V naught is nothing, it's the peak value. So peak value upon the root 2 is actually VRMS. Now here in this case, peak value is 50 root 2 upon root 2. So we can say that the RMS value of the voltage is here 50 volts actually. This is the VRMS, right? So if VRMS is 50, IRMS is 2, the value of XL is nothing, that's equal to 25. And we know it's actually equal to omega L, right? So from here, the L value is nothing, it's 25 upon omega, right? I can see here the value of omega here is given as 100 pi, right? It's 25 upon 100 pi. So value of L comes out to be 1 upon 4 pi Henry, right? So this will be the value of L, right? So this will be the value of L from this question, right? So this is how we can use the VRMS values, Excel, right? All these equation we can use, and we have to remember all these concepts to solve a problem in AC, right? Now let's move another question to another question, right? Calculate the impedance of the circuit shown in the figure, right? We have to calculate the impedance of the circuit. So we have the resistor here, right? And we have the capacitor here, right? We know in case of capacitors, the voltage leads the current, right? In case of capacitor, current leads the voltage, right? Current leads the voltage. In case of inductors, voltage leads the current, right? So drawing the phasor diagram between the two, right? Drawing the phasor diagram between the two, if this is the current I, right? If this is the current I, so this will be the current I, and this will represent the resistor as well, right? Resistance of this pure resistor, right? And we know the current leads in case of capacitors, right? By 90 degrees. So this will be the current because of the capacitor, right? This will be the voltage. The current leads in case of capacitors, right? So it means that this will be the phase difference, 90-degree of phase difference between current and voltage, right? Current will lead and voltage will lag, right? So from here, this will be the VC, right? This is the VC, right? Now, if we have to calculate, if this is the VC, right, this will be VR, right? So from here, the net voltage will be nothing. It will be under root of VC square plus VR square, right? VC square plus VR square, right? So talking about if this is V is equal to VC square plus VR square, now we know that the current they are in series, the current will be same, that will be I, right? I current will be flowing through it. Now let's suppose the total impedance of by this circuit is Z. So Z times I will be equal to V, right? Now we can write this VC square, that will be I square XC, right? XC square, and VR square will be nothing. It will be I square plus multiplied by R square, right? So we'll just take I outside. Taking I outside, we'll be left with R square plus XC square, right? So from here, that will be equal to ZI. I and I will get cancelled. So the total impedance will be nothing. It will be under root of R square plus X square, right? XC square, right? I can substitute the value of R, which is given as 30, and the value of X that's given as 40. So it will be nothing. It will be root of 30 square plus 40 square, right? 30 square plus 40 square, that will be actually equal to 50 ohms, right? So 50 ohm will be the total impedance offered by the circuit, right? Total impedance offered by the circuit will be equal to 50 ohms, right? Now let's move on to the another question. Find the required inductance to put in series of bulb to run it safely across an alternating supply of 100 volt, right? There is a 100-volt supply right here. There is a 100-volt supply and 60. This is the RMS value, PRMS value, right? And 60 hertz is the frequency of the supply. The RMS value of this supply is given as 100 volts, right? It's actually alternating supply, right? Now to calculate the current through this circuit, now the total maximum power absorbed by this bulb here is given as 10 watt, right? 10 watt. If 10 watt is the maximum power absorbed by this bulb here, right? We can calculate the current through this circuit, right? Current through this circuit will be nothing. It will be power upon the voltage, right? And VR is given as 60 volts here, right? It works on a voltage of 60 volts, right? We can calculate the current through the circuit as P upon V, right? That will be 60 upon, it will be 10 upon 60, right? 10 upon 60. That will be equal to 1 upon 6 amperes, right? 1 upon 6 amperes. So the current through this circuit is nothing. It's 1 upon 6 amperes, right? And this current will be an RMS value of the current because this has to be an RMS value of the current because in AC circuit the current continuously varies, right? So if this is the RMS value of the current, we can write that VRMS, right, is nothing. It's equal to IRMS into total impedance of the circuit, that is Z, right? Now the question is that if 100 volt is across this, right? 100 volt is across this and 60 volt is across this. Now what will be the potential across this VL, right? So we can write VL will be nothing. It will be the current multiplied by XL, right? Current multiplied by XL, right? So VL that has to be equal to 40 volts, right? It has to be equal to 40 volts, right? So 40 volt will be the average. 60 volt is across this resistor and 40 volt has to be across this. So it will be equal to 40. So current value of the current is 1 upon 6 and the value of XL is nothing. That's equal to omega L, right? So from here, the value of L will be nothing. It will be 40 multiplied by 60 upon omega. Now, omega is nothing. It's 2 pi times the frequency. The frequency is given here as 60 hertz, right? 60 hertz. So from here, this and this will get cancelled. This and this will get cancelled. So we'll be left with 2 upon pi. So the value of L has to be equal to 2 upon pi Henry. So this will be the required inductance or the required inductance value of this inductor to be put in series to run it, right? Now let's move on to the next question, right? This will be the last question of this session, right? Across two different inductors, same alternating source is connected. For this, Z versus omega graph is given, right? So Z versus omega graph is given. Find out L1 upon L2, right? So across two different inductors, we have been given same alternating source, right? The frequency will be same, right? We have to find, we have been given the total impedance, that is Z versus the omega graph, right? We have to find the L1 upon L2, right? L1 upon L2. So if we find the slope, since it's a straight line, so if we find the slope of this graph, tan of phi, it will be nothing. It has to be equal to Z upon omega, right? Z upon omega. Or if we find the equation of this, what we call as these straight lines, so it will be nothing. Z will be equal to m times omega, right? Z will be equal to m times omega, right? Or where m is nothing, it's the slope, right? Slope. Or we can write this slope as equal to tan of phi, right? Tan of phi. So from here, tan of phi is nothing. That's equal to Z upon omega, right? That's equal to Z upon omega, right? So if tan of phi is Z upon omega here, right? So we can replace Z here since it's a pure inductor. Z will be equal to omega L. So divided by omega, omega and omega will get cancelled. We'll be getting the value of inductance, right? We'll be getting the value of inductance in this question, right? Inductance. So tan of phi will give us the inductance value. So we can find the ratio tan of phi 1 upon tan of phi 2. It will give us the ratio between L1 and L2, right? The value of phi 1 is actually 60 degree, right? And the value of phi 2 is actually 30 degree, right? Tan of 60 is nothing, it's root 3. And tan of 30 degrees 1 over root 3, right? So it will be equal to 3 ratio 1, right? 3 ratio 1. The ratio between L1 and L2 will be nothing. It has to be equal to 3 ratio 1, right? So that's it for today's lecture. We'll be further discussing some of the important questions with respect to AC in the next lecture, right? Tomorrow. So we'll be stopping here, right? Till then, take care and goodbye.